use the linear regression feature on Desmos.com. Desmos is a free graphing calculator, which is great because it allows students to still have the capabilities of a graphing calculator without having to spend over $100 on the actual calculator. It's easy to use, so it's accessible to a lot of different people. The important thing is just knowing how to use those different tools, and the linear regression feature is a great one to get started with. So to begin, we would ask students to open up their Chromebooks and to open up Google Chrome. They would then go to their top bar and they would type in desmos.com and press enter. This is going to bring us to our home screen. From here we select Start Graphing, and that's going to open up our graphing calculator for us. The first thing that we want to do with linear regression is recognize the fact that our goal is to take a table of values and find what the line of best fit would be through those points. So we're going to start by clicking the plus button in the upper left-hand corner and select Table. Notice that in our table, our x values are identified as x1 and our y values are identified as y1. So those are lists that we're creating of those values. And we can type in any points that we want. So I'll type in a couple. I'm selecting just random points. However, you can collect data from different things. So you could do activities in your classroom with your students. You could find data from the real world. So you could look up or research a different topic. You can have students have some choice in that, which is kind of nice and gets them excited about the content that it is that they're learning. I've typed in a couple points. I have 6 in there, and you'll notice that those points don't create an exact linear function. That's where this linear regression feature is going to become handy. So as you type in each point, it shows up on your screen in your coordinate plane. Next, I'm going to open up a new bar, and in that new bar is where I'm going to type in the equation that's going to do the actual calculation for us. I'm going to tell my computer that I want you to bring in my list of y values, and you'll see that it's identifying I have 6 values in this list that you're calling y1. Next, I'm going to click Shift and then the button above Tab, and that's going to bring in a squiggle, which is saying this is going to be an approximation. It's not the exact line, but it's as close as we can get. We're using slope-intercept form because it looks like a linear function, so I'm going to bring in m for my slope, and already we see that the computer is starting to calculate some different things for us. Next, I want to bring in my x list, so x1. So now I'm including my y values, I'm including my x values, and I'm telling it I want to calculate slope. And the other thing that I want to calculate is my y-intercept. This black line that's come up on our screen is the line of best fit, and we get a couple different characteristics that help us describe it. 2 things that we care about especially are our slope and our y-intercept, which are under our parameters. So the slope is m, and we see that our slope here is negative 1.657, and our y-intercept, or b, is negative 2.15. So this is showing us that based upon the points that we have, that is our line of best fit slope and y-intercept. If I were to change any one point in my table, notice that my values for my slope and my y-intercept change as well. So it is completely dependent upon the points that you're putting in there. The next things that we want to identify are under the statistics section, and that's our correlation coefficient. Our correlation coefficient identifies how strong the relationship is between the line of best fit and the points that we have in our graph. So the closer that it is to either +1 or -1, the stronger the relationship is that we have. The final thing that we can use, which is nice about Desmos, is that in this line, as you drag along it, you can see any of the points that fit into this line of best fit. So if we wanted to do some kind of an estimation, either interpolation or extrapolation, so going within the points that we know or going beyond the points that we know, we can take this equation which is y equals negative 1.65714 x minus 2.15238. Typically, I tell my students to round to the hundredth place, but it's just kind of dependent upon what it is that you want to focus on. From here, they can see what would be our best estimation if we were looking for an x value of 2.5, so beyond the point that we know. And we see in the corner that y would be equal to negative 6.29523, which makes sense with our trend of data that we have a negative correlation, so it would be going down. So I hope this was helpful in kind of seeing how simple it can be to use the linear regression feature of Desmos. Thanks for watching.